In this work, we visualize a directory structure in augmented reality as a hierarchy of interactable nested bubbles, allowing a user to traverse the directory in a way that most naturally suits an AR environment. The bubble metaphor seeks to bring the advantages of the familiar files and folders directory representation to AR. It has broad applications. In our implementation, we chose to use the metaphor to display an art gallery, with the content organized into bubbles and sub-bubbles. When we look at content on a computer, we are often aided by a metaphor. Units of content are files, and those files are organized using folders. To say this metaphor has been successfully adopted would be a vast understatement. The tried and true visual metaphor has become so ubiquitous that it's difficult to separate it from what it represents. In many people's minds, files and folders are the directory structure. What would a PC without them even look like? But although this system works well in the flat environment of a PC desktop, it does not translate readily to the three-dimensional space of augmented reality. It is, of course, possible to display files and folders in AR, but doing so does not take advantage of the immersive quality of that space. When we overlay virtual and physical worlds, it seems natural to expect that the elements we place in that hybrid environment should be hybrid in themselves. Their virtual qualities should be anchored to the physical world. Our app, Step into the Bubble, aims to meet this goal by representing hierarchically organized information as a set of nested bubbles, which surround the user in the AR space. Just as a user can descend into deeper and deeper folders and subfolders in a typical file system, so too can they traverse our bubble hierarchy by entering bubbles and subbubbles. The experience is tied to the physical space around the user, giving them a gallery-like experience that is both intuitive and immersive. A major advantage of this system is that it can be deployed anywhere, allowing museums to move outdoors with the help of just a poster and a phone. Step into the Bubble is an Android app created in Unity using AR Core. When a user scans a special poster with the app, it reads a directory structure from a JSON file hosted online, constructing a bubble hierarchy from the image URLs and other metadata contained therein. This content package is then saved locally and identified with a key, so that each package only needs to be downloaded once. While the content is being prepared, the user is prompted to look around with their AR device in a brief interactive sequence, which gives the app a chance to scan the physical space and find the ground. Then the content appears, and the user can begin interacting with it. If the user steps into a bubble or taps it, the entire content hierarchy is scaled up to make the selected bubble's children the appropriate size to be observed. The user is then inside that bubble and can look around to interact with the content it stores. Tapping another bubble means going into a deeper gallery level and seeing a new assortment of content. When there are no more sub-bubbles to enter, content is displayed in a frame. Each frame can optionally be associated with a web URL where a user can find additional information related to the content. There can be a mix of bubbles and frames on any given level, and the platform supports an arbitrary number of levels. If the user taps anywhere other than on a bubble or frame, they exit the current bubble. The hierarchy is scaled down so that the user is back inside the bubble's parent. There is also a special bubble positioned near the floor, which will bring the user all the way up to the topmost level. A key challenge of working in AR is effectively communicating to users that they should observe the space surrounding them while using the app. Initial testers of the app would sometimes scan the poster and then not turn away from it, unsure of what to do next. Or they would enter a bubble, not see any child bubbles directly in front of them, and then not realize they should look to their left or right. We sought to address these situations with many small improvements. Animations to hint to the user that objects may be to the side or behind them, continuous transitions between content levels to prevent the user from becoming disoriented, carefully worded pop-ups to tell the user where to look, and so forth. On the topic of challenges, another one we faced during development was keeping the transitions between content levels continuous, to prevent users from becoming disoriented and also to help them perceive the bubbles as a nested hierarchy as intended. This challenge of user experience design demanded a fair amount of iteration during development because it involved several competing requirements, including constructing the hierarchy at runtime with no hard-coded elements, supporting an arbitrary number of levels and irregular trees, making it clear that the user enters a bubble when they tap it, not overwhelming the user with too many bubbles on screen at a time, and allowing the user to traverse the hierarchy in both directions, in and out. The resulting transition is as smooth and simple looking as possible. The user should be aware only that the bubble they tapped grows to envelop them. The entire content hierarchy must always move as a unit to preserve this illusion of nestedness. In addition to computing the correct position, orientation, and scale of the hierarchy, colliders must be switched on and off, Bubbles and their shadows and content must be crossfaded, the spinning animations must be started and stopped, and everything must occur over time using tweens. Currently, the Step into the Bubble app is a proof of concept that demonstrates how a directory structure can be translated to an engaging AR experience. In order to make the app a fully featured authoring tool, several features would need to be added, including the following. Multiple content packages. The app currently downloads the content it displays from the web so that an author can customize the app's content just by editing the source JSON file. To support multiple content packages, the JSON source file can be replaced with a database of such files, each keyed to a specific AR target poster. As a result, whenever the user views a bubble-enabled poster, the app would identify and download the associated content package, then proceed from there. Greater author control. The JSON source files allow authors to specify the structure of the bubble content hierarchy, the images and text that are displayed, and the web pages to which the frames point. With some modifications, the source files could also let the author specify additional elements as well: bubble size, pop-up text and images, and sound effects or other audio. Additional content types. Although the app's current implementation can only display image and text content, it is possible to support other types of content as well, such as video, audio, and 3D models. Additional interaction options. Though the initial goal of Step into the Bubble was to enable museum and other art-based experiences to be made portable and accessible, the prospect of also enabling users to extend and personalize such an AR-based experience demonstrates the power of our approach. In the current implementation, a user of the Bubble app is an observer, viewing a particular content package without adding to or modifying it. However, the app can also be enhanced to support a whole new level of user interactivity and engagement by allowing users to not only add feedback and comments to each bubble, by pinning them to particular locations in 3D space, but to also create new bubble experiences with links to their own content.